Welcome to the deep dive. Today we're getting into something pretty revolutionary, a technical specification called the Experience Semantic Protocol, or ESP.
That's right. It was authored by Damir Ulovich back in September 2025. And it tackles this, well, huge problem in how we communicate.
Which the paper calls catastrophic compression, right? Sounds dramatic.
It kind of is, actually. I mean, think about it. Your brain is processing experience maybe 10 million bits a second.
Okay, yeah, a lot going on in there.
But when we use language, we're squeezing all that down to like maybe 50 bits per second.
50, that's an incredible loss. Thousands, tens of thousands of times less information getting through.
Exactly. That's the catastrophe. The source uses this great analogy, the Adriatic moment.
Yeah, I remember that part. You're on the cliffs, feeling the sun, smelling the pines, the sea. It's this whole sensory and emotional thing.
Right, this profound feeling of serenity, maybe the ancient rhythm of the place.
And all you manage to say is, wow, nice sunset.
Precisely. You've just compressed this rich, multi-layered experience into a simple, almost meaningless symbol.
So ESP is trying to, send the whole feeling instead?
Essentially, yes. Not the raw brain signals, but a structured representation of the experience. The goal is to transmit typed, latent representations of it.
Typed and latent. Okay, break that down.
Well, latent means the underlying pattern, the essence. And typed means it's categorized. The spec aims to keep maybe up to 40% the original meaningful neural data.
What, 40%? Why not aim higher? Is that just like a technical limit?
It's less a limit and more.
Yeah.
A target for functional transfer. You don't need every single neuron firing copied. You need the core information that makes the experience what it is operationally. 40% is identified as potentially enough for that.
Okay, so you're sending this condensed essence. How do you package it so it makes sense, so it's not just noise?
That's where the typed part comes in with something called TAOSS, typed approximately orthogonal semantic subspaces.
Whoa, okay. TOSS sounds complicated. Let's maybe simplify that a bit.
Yeah, forget the acronym for a sec. Think of it like an experience genome. Just like DNA has 4 bases, TAOSS breaks experience down into roughly separate orthogonal types.
Orthogonal meaning?
Meaning they're mathematically distinct. Knowledge doesn't automatically bleed into emotion, for instance. They can be handled separately.
Got it. So what are these types?
There are 5 main ones outlined. Knowledge, KNO for facts. Intention, INT for goals or desires. Emotion, EMO for feelings. That one's crucial for privacy.
We'll definitely come back to privacy. What else?
Sensory, SEN, that's raw perception, touch, taste, sight. And temporal, TEM, which is about rhythm, timing, the flow of things.
Okay, I can see how breaking it down helps. Let's talk impact. The paper mentions job learning, right? Skill transfer.
Oh, absolutely. This could be huge. Think beyond watching a YouTube tutorial. Imagine a surgical resident.
Instead of just watching a master surgeon.
They could receive the experience vectors, the precise steadiness of the hand, that's SEN, sensory data, the intuitive timing for a delicate step, that's TEM, temporal.
And maybe even the feeling of confidence.
Exactly. That could be a mix of INT, intention, and maybe some EMO, motion like focus, calm. The idea is the actual feel of the skill, the craft, can be passed on directly. It could outlive the person.
That's incredibly powerful. But it also sounds incredibly risky. We're talking about sharing internal states. How do you prevent this becoming, mind reading against someone's will?
That's a core concern, and the protocol was supposedly designed with that front and center. Because, let's face it, with BCI, brain-computer interfaces, getting better, this kind of transfer feels almost inevitable.
So safeguards?
Yes. Privacy-first design. The key is selective sharing and needing explicit cryptographic consent. And critically, the emotion stream, EMO. That's masked by default.
Masked by default, meaning you have to actively choose to share your feelings.
Precisely. So the surgeon could share the hand steadiness, the SEN data, without automatically sharing their personal anxiety or maybe a traumatic memory associated with a past case.
But is that separation really possible? Can you perfectly isolate the skill feeling from the personal feeling? Don't they sometimes mix? Like, doesn't anxiety affect hand steadiness?
That's the goal of the orthogonality we mentioned. The mathematical separation aims to isolate the functional component, the steady hand movement pattern, from the concurrent but separate emotional state, like anxiety. It's about isolating the transferable skill element.
Okay. It relies heavily on that mathematical separation being effective.
It does, and it's key for ethical use. The big picture here, the ultimate direction, is potentially moving beyond language as our primary way to connect deeply.
Post-linguistic communication.
Yeah. Even if the first versions, like a basic level 1 profile, are imperfect, only transferring a fraction, it's still a fundamental shift. The source puts it starkly. Even imperfect experience transfer obsoletes perfect language.
Wow. Okay, that really lends to the potential scale of this. Imperfect experience beats perfect symbols.
That's the core takeaway.
So, to leave you, our listener, with something to think about, if you could download a skill, an experience, instantly using something like ESP, what would you choose first? And maybe more importantly, thinking about those types, knowledge, sensory, emotion, what would you be willing to share in return? What level of connection are you ready for?